Hello, good evening. How are you doing? Is this, let's see, Jenny with me? Yes, good evening, everybody. Welcome to Professor T.K the Chemist Live. Tonight, we're going to be learning stoichiometry. And for those of you all that are not familiar with me, we actually get into a lot of different concepts for chemistry. So I just want to know who's in the room. Who's in the building? Who wants to learn chemistry? Tell me, what are you guys actually learning right now in your chemistry class? And if you don't mind, go ahead and put that in the chat box, what you guys are learning in your chemistry classes, because that's going to be the thing that we actually will go through. And also, while you're in here, make sure that you guys are tapping the screen and meaning thumbs it up, like the video, so that we can get this out to other people that need to know about what we're doing. I know that this is the time of the semester where so many students are struggling with chemistry and they don't know if they're coming or going. So for those of you guys that are in here tonight, can you all tell me, yeah, okay, yeah. So you're from New York. Okay. That's right. I remember you told me that this morning. You are taking the NLN. So I actually did a little bit of homework and I looked it up. So this is the test that you're taking in order to get into the nursing program, or is it an exit exam that once you finish the nursing program, you're good to go? Because I know that so many students, for instance, I do a lot of stuff for the T7 chemistry part of the nursing exam. And yes, okay, so it's similar to the T's exam. Okay, so for those of you all that are taking chemistry, can you tell me what is your biggest fear in chemistry? Yes, matter of fact, let me go ahead and pull up some stuff for you all because I want to know what is your biggest fear. Okay. And let me tell you guys why I'm asking that question, because so many students don't realize chemistry is one of those things where you have to stay on your P's and Q's, right? You have to be on your P's and Q's. So there are 6 concepts that many students have to know in order to take what's called the T7 exam. And let me just kind of pull up something for y'all, okay? So chemistry in general, okay. All right. Let me ask you this. Let me see here. Let me do something. Let me go to my page here so I can actually show something to you all. Okay. So right here, like this is something that I actually offer to students that deals with the T's exam. And I know that so many students are actually struggling right now. So let me pull up a document for you all, okay? So that way you all can see something for a quick second. Now, in chemistry, you have to be organized, okay? You have to be organized. And let me tell you why. Because when you are not organized, like this periodic table, for instance, you're going to be on the struggle bus. So what I'm going to do, I'm going to actually pull this down for a second so I can pull up some stuff for you all. And I need to know, pretty much what you guys are going to be needing to know for your own assessments in your class. Okay, so give me one second. Okay. As a matter of fact, all right, here's one thing that we could actually start with, okay? I'm going to, hold on, because I have several different files up, and I want you all to be able to kind of see certain things that I'm doing right here, okay? All right. So I hope you guys got your pens and papers, because what we're getting ready to get into tonight will kind of give you all the general consensus of what you all need to know in chemistry overall. Okay. So here we are. So in chemistry, one of the things that you have to do, if we start with the foundation, all right, I always take students through this concept here of knowing the building blocks, right? So when you look at your periodic table, on your periodic table, there are different concepts that you need to know. And in a basic introductory class, we typically start off with protons, electrons, and neutrons. Now, one thing that you guys got to keep in mind is that the periodic table is structured in a way in which you can learn all of the concepts that you need to know. All right. Now, in order to understand stoichiometry, which is what the title of this video was talking about right here, let me show you so you can see. Okay. You have to know how to even work the problems by knowing how things are located on your periodic table. So for instance, I'm going to share with you all right here, just as an example here, so you all can see what I'm saying. All right. So if we take stoichiometry, for instance, right, and you are given a balanced equation, sometimes your professors will not have this equation already balanced. So if that is the case, if your equations are not balanced, you're going to have to do that first part. So this is the first part right here, right? Hey, good evening, Drew. How are you? Now, here's the thing. If I give you a stoichiometry problem like this, and I say, all right, I need you all to find the moles of water produced from 3 moles of hydrogen, what you have to do is determine what are they asking me in this problem. So let me go ahead and cut this picture for a second. Let me go ahead and crop parts of it so that we can just focus on one part of what we need, okay? So I'm going to break this down in the simplest way possible so that you guys can get this. All right. So one thing I will tell you all is that when you are doing stoichiometry problems like this one right here, one thing I want you all to do is to look at what's given versus what is required, okay? Look at what's given versus what is required. So in this particular problem here, you already see that you have 2 moles of hydrogen, right? That means you're going to look at the coefficients right here. The coefficient tells the story. So you have 2 moles of hydrogen. You have 1 mole of oxygen that's producing 2 moles of water, okay? Now, what this means is if you look at the number here, the numbers that are in front, those are coefficients that we use in order to determine how many liters we have of certain things or how many moles we have of certain things. In this case right here, we're going to look at moles, okay? So stoichiometry, which is this concept that we're talking about, stoichiometry is pretty much like baking a cake, okay? It's like baking a cake. So for instance, if I tell you that it takes 2 pieces of bread plus 1 piece of meat to give me 1 sandwich, what happens if I decide that we're going to, let's say, double the piece of bread, right? Well, that means I'm going to need 2 pieces of meat to give me 2 sandwiches. That's what stoichiometry is. You are basically looking at what's given versus what's required in your problem. So now I'm going to go ahead and share this example here with you so you can see what I'm saying. All right. So in this first problem, we're going to start off with letter A. It says, how many moles of water, this is what we're talking about right here, are produced from 3 moles of hydrogen? That's that number right there. Okay. So what you're looking at here tells me what you started with versus what you're going to. What you start with versus what you're going to is how you move according to this problem. Hello, Ridwayne, how are you? So now I'm going to take the starting number right there. You see that 3 moles? That's what they gave me in the problem, right? 3 moles of hydrogen. Now, what am I going to do? I'm going to go back to my balanced equation right here. You see this, guys? Okay, see this? Right here. I am going to use the 2 on the bottom right there because that's what it was initially in this reaction. And what I'm trying to determine are the moles of water. So that 2 right there goes on the top right here. So 2 moles of H2O. Now, what you're going to do, you're going to go ahead and cross out your moles of hydrogen because you no longer need that anymore. And so now you end up with saying 3 times 2 is 6. 6 divided by 2 gives you 3 moles of water. All right? That's how you do stoichiometry problems. That's what it means when we talk about mole to mole conversions. So if you are in chemistry, this is something that you're probably learning right now, or you have already learned and you got to expand on it for later. All right. Now, let me show you guys another example. We're going to look at part B. Okay. So I'm going to erase this part right here because now when we look at part B, it's a completely different type of question. Okay. So let's look at part B. We have the same chemical reaction, so we're not going to get rid of that. But take a look at what they're asking us in the problem right here. So let me go ahead and highlight this for you right here. It says how many moles of oxygen? See that right there? How many moles of oxygen? So I'm going to put an X right there over oxygen because that's what I'm looking for. Are needed to react with 5 moles of hydrogen. So right here up above hydrogen, I'm going to put the 5 moles. Now, they did not say anything about water, so you leave that part alone, okay? They did not say anything about water, so you leave that alone. So now, take a look. If my initial recipe calls for 2 moles of hydrogen, but then all of a sudden it goes up to 5, by what factor did this change by? By what factor did this change by? It changed by 2.5. And how do I know that? Because look, if it started off with 2, then it goes up to 5. That's where the 2.5 comes from. But for those of you all that are saying, all right, I don't get that, let me show you. Take the number that I wrote in blue, the 5 moles of hydrogen, because that's what they gave us, right? Now, on the very bottom, I'm going to go to this coefficient right here, that 2, and I'm going to put the 2 moles of hydrogen on the very bottom, just like that. Now, you see where I put the X right here? Guess what? That coefficient of 1, that imaginary 1 right there, that's going to go right there on the very top. 1 mole of oxygen. And so what I want you all to see here is that this part that I boxed in are my coefficients from the balanced equation. All right. I have 2 moles of hydrogen on the bottom. I have 1 mole of oxygen on the very top. And all I'm going to do is cross out my units that I don't need anymore. So now all you have to do is plug this into your calculator. 5 times 1 is 5. And then divide that by 2. And you end up with 2.5 moles of oxygen. Okay? Stoichiometry is that simple. Okay? It is that simple. Now, so far, does anyone have any questions about what we're doing here? Because I want to prepare you all for your final exam, because I know that some of you all are going to be taking the final exam soon. And so we want to make sure that you guys are good to go. So let me find some more practice problems for you all, okay, as we kind of move to the next part of what we are doing. But does anybody have any questions on stoichiometry? Now, I'm going to put another example up here, okay, so that we can kind of do this together right here. So I'm going to make one off the cuff, all right? So here we go. Let's say that you have lithium bromide, right, plus chlorine. That's producing lithium chloride plus bromine. Now, in any stoichiometry problem that you do, you must make sure that this is balanced, okay? Hey, Jules, you said, how do you find the mass? Well, we're going to get to the mass part. So if we were doing, let's say, a mass problem like this one right here, okay, since you asked, let me go ahead and show that to you. Like this one right here, moles to grams, what you would have to do is look at your periodic table to find that, okay? You have to look at your periodic table to find that. And as a matter of fact, we'll go through that one in a second, okay? I'll make sure to do that one for you in a second. And so speaking of that, okay, if I give you a problem like this, you can see right now that this equation is not balanced. So what we have to do is make sure that we balance it out by saying, all right, well, I know I have one lithium on the left, one lithium on the right. So far, that's good. One bromide, two bromides, two chlorines, one chlorine. So what I'm going to do first, I'm going to start off with the bromide. I have two over here on the right. So I'm going to put a 2 right there on the left. And now, not only did that change my my bromide, but it also changed my lithium. So I'm going to put a 2 right there in front of lithium chloride. And now that also increased chlorine. So now this is balanced, right? It's balanced. So if I said, okay, I'm going to just give you all a problem right here. Suppose the question says, how many moles, okay, of lithium chloride will be formed with 0.046 moles of lithium bromide, okay? Now, here is your question right here, and I'm going to explain this to you, okay? So it says, and let me make that a little bit neater. There we go. How many moles of lithium chloride will be formed with 0.046 moles of lithium bromide? Okay, and I need to add something in here. I should say when 0.046 moles of lithium bromide reacted with chlorine. All right, this is your question right here, right? So if I say moles and moles, this is a one-step problem, okay? Mole and moles are one-step problems. How do I know that? Because in stoichiometry, mole to mole just simply means to look at your coefficients and use that. Now, if we were talking about grams, then that would be a different story, okay? So right here, because I said how many moles of lithium chloride, right? So I'm going to put an X above that because that's what we're talking about. Will be formed when 0.046 moles of lithium bromide reacted with chlorine. Now, let me tell you guys a little secret right here. If the coefficients are the same and you're dealing with moles and moles, guess what? This is a one-step process, and that means that if this number is 0.046 moles, guess what? So will this one as well. That one will also be 0.046 moles. But to prove that point, let's go ahead and solve it down below. I'm going to take that starting number, 0.046 moles of LiBr, lithium bromide, okay? That's what I'm going to start with. In this box right here, okay, I'm going to go to my coefficients from the balance equation. You see the lithium bromide right here? I'm going to put that right there on the bottom. And I'm going to go to my balance equation. See that too? That's going to go right there in that box. On the top, I'm trying to get to the moles of lithium chloride. So guess what I'm going to put on the top? Moles of lithium chloride. And I'm going to go to my coefficients right here. And I'm going to put a 2 right there. Now, for those of you all that see this, when you have the same number on the top, guess what? They get canceled out, okay? They get canceled out. So we really don't have to use those 2's in the problem, but if you wanted to plug it in, you could. 0.046 moles times 2 divided by 2 is going to give us 0.046 moles of lithium chloride. Now, someone asked me earlier, how do you find the mass? Well, that's when you're going to have to use your periodic table to determine that, all right? So if I ask you in this same problem over here, I'm just going to kind of do this as a sidebar. Suppose they ask you to find the grams of lithium chloride, right? If they ask you to find the grams of lithium chloride, then you would have to find the molar mass of lithium chloride. So that means I'm going to have to use my periodic table, and I think I have one here attached in the notes down below. I think I do. Yep. Here we go. I'm going to go back up here so I can insert it. Okay. So I'm going to have to use my periodic table right here. But let me zoom out because it is pretty big on the screen. Okay, here we go. And thank you all so much for those of you all that are in here. I appreciate you guys for showing up tonight. I appreciate that. I normally go live on TikTok, but I'm trying something different with YouTube so that, hey, I can, be over here and present with you all over here on YouTube, okay? And make sure that if you guys are not following me, that you do follow Professor T.K the Chemist. So now we were looking for the molar mass of LiCl, right? So to find the mass, you have to find the molecular weight for lithium is 6.941. You're going to add that with chlorine's weight of 35.45, okay? So let me go ahead and do that now. So right here, if I ask you to find the grams, okay? This is the one we were talking about over here. If I ask you to find the grams, you have to determine the molar mass of LiCl. Lithium was 6.941 plus chlorine's 35.45. So we're going to grab our calculator right here together, 6.941 plus 35.45, and you get 42.391. But significant digits, we only need 42.39. And that's grams per mole, okay? That's the molar mass. So if I told you to convert that 0.046 moles of lithium chloride to a gram, guess what? You're going to have to put the grams right here on the very top. So that's going to be 42.39 grams of lithium chloride on the very top. And you know what goes on the bottom? That mole. So you're going to say 1 mole of lithium chloride. Now, all you have to do is cancel out your moles of lithium chloride, okay? Because we don't need that anymore. That no longer serves us. And so now you just multiply those two numbers, okay? 0.046 times 42.39 gives us, and we go with the least of these digits, so we only need 2 in our answer, 1.9. So our answer here is 1.9 grams of lithium chloride if we had to find that, okay? That's how you do stoichiometry with mole to mole, and then in this case, mole to gram. All right. Now, let's do another example here of mole to mole, okay? So I'm going to take this problem right here. Let me see. And listen, guys, If you all are having trouble in chemistry, I have playlist upon playlist of examples that you guys can actually utilize in your studies so that you're able to kind of grasp some of these concepts a lot better. So for those of you all that are struggling in chemistry, I have a ton of playlists of examples that you guys can actually follow, okay? So here is our next example right here, okay? So, and I'm going to zoom in so you all can see the problem, okay? All right. So this problem says, given the balanced equation, okay? So let's say that we're only going to look at letter A, all right? Just focus on letter A. Let me go ahead and write out the equation again because we're going to need this. All right. How many moles of NH3 are produced from 4 moles of N2? All right. So what are they talking about? They're saying how many moles of NH3 are produced from 4 moles of N2. Guess what? You see this coefficient here. This was your original recipe. 1 mole of nitrogen, 3 moles of hydrogen, 2 moles of NH3. Well, my recipe changed. I now have 4 moles of N2. I'm trying to determine my moles of NH3. This is easy. Look, when you have whole numbers like this, it makes life so much easier. All you have to do is say, all right, well, if I originally start off with 1, but then it quadrupled, guess what? This answer here is going to be 4 times the amount also. So that means my answer here is going to equal to 8. Now, I know some of you all are like, wait a minute. How do you do that? Let me show you. We're going to say 4, start off with the number that they give you in your problem. 4 moles of N2, that's your nitrogen, times. Now, remember, I'm going to zoom out a little so I can have this. So I can have some space here so y'all can see this. Okay. I've got 4 moles of nitrogen. That's what they gave me in the problem. On the bottom, I'm only going to focus on this one and that one. I have an imaginary 1 right there. Guess what? That 1 is going to go on the bottom. That's 1 mole of nitrogen. I'm going to get rid of those units. Now, again, refer to your coefficients. We're trying to find the moles of NH3. So guess what? If we looked at our balanced equation, that 2 is going to go right there on the top. And this is what we're looking for. So what's 4 times 2? 8 divided by 1. 8 moles of NH3 is your answer. Okay? 8 moles of NH3. Does anybody else have any questions so far? And if you are confused, let me know that too. All right. I want to know how you feeling. And those of you all that are still in here, what questions do you have? Okay. Now I'm going to put a poll here, if I can. So that way you all can answer, the question. And I just want to know, what chemistry are you taking? Are you taking General Chem 1 or Intro? Or are you taking General Chem too? Okay. So I'm trying to put a poll here. And hopefully you guys will be able to see that. Okay. I'm trying to make sure it's not in the way because this is my first time using this. Okay, intro. Okay. So, Jenny with me, what are you learning right now in your chemistry class? Can you tell me? Or what concepts are do you need further assistance on? Okay. Okay, starting with the periodic table. Okay, got you. All right, so here's what I'm going to do. Since you mentioned the basics, okay, let's go back over here. The periodic table, okay? So let me go ahead and I'm going to drag that right there. Okay, so here we go. When you look at the periodic table, it is designed so that you can get certain things, certain concepts that you need, right? But here's the thing. Sometimes on these assessments, they're not going to always give you the periodic table, but let me show you what they would give you. Just as an example. Okay, let me scroll on down. Okay, just so you all will know. They may give you something like this, where it's just some of the numbers, some parts of the periodic table. So let's just start here for a moment. In each of the periodic tables that you see, you're going to be given the symbol, okay, the name, the mass of that element. Okay, let me zoom in so you can see that even further. Okay, the mass of that element, which is usually a number with a decimal, and then on the very top is the atomic number. Now, when you are given those things, this kind of tells you everything you need to know specifically about that element. Now, there are other things that you'll have to know also about it, such as what's the charge for this element? Is this element a metal? Is it a non-metal? What's the electronegativity? Those are the key things that you have to know from looking at the periodic table. Now, how do you find this out? Let me show you. When you study the periodic table, there are certain things that you will be able to do, once you get the handle of it, right? So, for instance, if you take a look right here, the periodic table is designed such that all of your metals make up, I would say, 85% of this. So you have group one over here, group two. There are 18 groups, by the way. Okay. There are 18 groups here, so that way you can see that. Matter of fact, let me write it out right here. Group one, group two. This is groups 3 through 12 right here in the middle. Then over here, you get to group 13. And you know what? I'm going to actually change the color also when we get to those that are negatively charged. Then that's group 14. Now, when you get over here to groups 15, 16, 17, and then technically with 18, it doesn't have a charge. What you will find is that the charges tells you how they go together, how you get what's called an ionic bond. And ionic bond is when you're taking anything in blue, combining it with anything that's in purple. However, if you have anything in purple, combining with anything else in purple, those are covalent bonds and they do not swap charges. But anything that you have that's in blue, swapping with purple, they're going to swap charges and then you're going to get the name like sodium chloride, for instance, okay? Or lithium chloride, like what we talked about earlier. So if I say I have lithium, which has a +1 charge, and then let's say I combine that with, let's say, oxygen, okay? Oxygen over here has a -2 charge. In chemistry, we know that these are going to swap. Lithium is going to take that 1. Lithium is going to take that 2, and oxygen is going to take the 1. But the 1 is understood. So in chemistry right here, this is where you have the charges of your compounds. Okay, so this is just an overview. I'm just giving you like a little snippet of what you would have to know in your chemistry. Okay, now one thing I can tell you guys, I actually sell this guide right here because it's like it gives students an idea or a way in which they're able to have all of everything at your fingertips, right? And this guide right here shows you, for instance, the charges that I was talking about. Yes. Thank you. You're welcome. You're welcome. And and it's 11 by 17. That's why I can't like show it to you the full way, because I mean it's that long, right? But inside this guide right here, I'm just going to kind of give you a little snippet. I have all of the names of the prefixes with their names, numerical prefixes, those charges that I mentioned a second ago, and the names of the polyatomic ions. And then I also give you like some memory hacks as well. Okay. And those memory hacks are there so that you're able to kind of remember certain things that are going to come up on your test. And then over here, the valence electrons, how all that works. And then the names of those of those groups. I know a lot of times when we're talking about chemistry, there's so much to remember. But I have this little guide here because even though you may have your book, sometimes you need to just go straight to something like this. Okay, and it's on like pretty sturdy, like it's like a plastic sturdy chart. You're able to use that in a quicker way rather than thumbing through all of your notes. Okay. But yeah, I mean, I have so many different resources that you all can actually benefit from, so that you're able to, be proficient in your studies. Now, I know that you said you were taking your exam in the fall. So what I would recommend that you do is take 1 chapter a week, and just do practice problems. Just do practice problems, read over it, make index cards. I always tell my students to make index cards. Like if we're talking about the gas law, like this, for instance, I mean, I use my Cricut machine and I this out, but this is just to help students remember certain concepts. The more you write it down, the better you'll become. Okay, the better you'll become. So don't let this periodic table scare you. Okay, I know it looks intimidating, but there are certain things on here that once you figure everything out, it'll all make sense. Okay, it'll all make sense. Now, if I were talking about protons, electrons, and neutrons, it's the same thing. I would have you, know that you look at your element. Like for instance, let me zoom in again so you can see this, okay? So let's say that we were looking at, let's see. Let's look at, we've been talking about lithium tonight. So let's look at lithium, okay? See that? Lithium, and I know it's small right here, but with lithium has an atomic mass number of 6.941. But if we were talking about finding the protons, electrons, and neutrons, I would have to round that number up to 7 in order to do that, okay? I would have to round that number up to the number 7 in order to do that. But you will learn these tricks of the periodic table as you go through different concepts. So if we were talking about going back to the beginning, this is where we would start here with just knowing where these things are on your chart. What does each of those numbers represent? How do you categorize them? Yes, you round the number when you're talking about protons, electrons, and neutrons, But if you're talking about molar mass, like stoichiometry, the stuff that I opened up our lesson with tonight, guess what? You do not round off, okay? The only time you round off in chemistry with the numbers that are in the periodic table is when you're talking about protons, electrons, and neutrons. That's the only time. Any other time, you keep the numbers that you see as they are. Yep. You keep the numbers as they are. So let me see. Oh, so here's a good example right here. And this is what I was going to talk about earlier. Okay. So let me zoom back in here so you can see that. Okay. So right there, okay, protons are positively charged particles in the nucleus. Neutrons are neutral. And electrons are the little busybody ones that are on the outside. So if I were to tell you, like you all may have seen this before, of the atom, just like this right here, right? You've seen this little structure before, the atom. Well, in the middle, you have your protons and your neutrons. And guess what? Together, they produce the mass. They produce the mass. Your electrons are those little blue parts, those little blue dots, okay, that are orbiting around the nucleus. But now here's something else you need to know. When we talk about calculating, okay, and using this information, I'm going to go back over here to this part that I was talking about earlier to show you how you do need to round off right here. So here's an example. Okay, if I tell you to calculate the protons for lithium, let me zoom in so you all can see that right there. Okay. Okay, so you see lithium has a mass number of 6.941. But in chemistry, when we are talking about calculating the neutrons, okay, you have to take the mass number, which is 6.941, but you round it off to the nearest whole number of 7, and you subtract that from the atomic number, which is 3. And so the neutrons for lithium is 4. My protons and my electrons are typically equal to the same number, which is 3. My neutrons is when I take the mass number here and I subtract it from the atomic number, but your mass number must be rounded off to the nearest whole number. So if we look over here at hydrogen, okay, the protons for hydrogen is 1. Electrons for hydrogen, also 1. But now my neutrons for hydrogen, I'm going to take that 1.008, I'm going to round it off to just 1. And I'm going to subtract it from my atomic number of 1. And that means I get 0. Okay? This is just for the regular element. But if we were talking about an isotope, then that's a little different. Okay, that's a little different. But we'll get into all of that too later on. Tonight, I just wanted to come on here to see what you guys were interested in learning so that, we do these lives. We'll be doing them twice a week on Tuesdays and Thursdays. So that way you guys are able to, get the help that you need. And I do have access to all these worksheets and stuff if you want. Yes, hydrogen does have a mass number. Yep, it has a mass. But the neutrons, it was what we were looking at right here. That was 0. So right here, here's hydrogen. Right there. If I can get it to stabilize, there we go. Okay, so right here, hydrogen has a mass of 1.008. In order to calculate the neutrons, you must round that number up to just 1. So that's 1 minus 1 gives you 0. And that's what we were doing for lithium. We rounded up to 6.941 to 7. 7 minus 3 gives you 4. And that's for your neutrons there. If I look at carbon right here, that 12.01, that gets rounded off to 12. And the atomic number here is 6. 12 minus 6 gives you 6 for your neutrons. Okay? All right. So yes, I look forward to you guys coming back on, with me at on Tuesdays and Thursdays. Unless something has come up, I'll let you guys know, and I'll actually, post the schedule on my wall so that way you all will know when I go live. But for the most part, it'll be on Tuesdays and Thursdays. And if you all want to follow me also over there on TikTok, you sure can. You can come on over to TikTok and see me go live as well over there too. Okay? So I appreciate you guys for stopping by. This was just a tester tonight, to kind of see, how to work this thing out with YouTube and going live. And I think we're going to make this a weekly thing on Tuesdays and Thursdays. Okay? I thank you guys so much for popping through, and this live will be available soon as we hop off. All right? Do you all have any more questions? All right. Oh, yes, of course. Of course. And you know what? I appreciate you for coming in. And I actually take my time. Whenever I teach, I make sure I answer all of your questions. And, I just want to make sure that you are good to go, when we go through these types of problems. So if there is something that you want to see me do, if I haven't already done it, I'll do it for you. Because I have a whole bunch of worksheets and stuff that I can pull from, because I've been teaching for a very long time, okay? A very long time. So I've got plenty of resources that I can utilize to help. But I definitely appreciate you as well for coming through. And if there's anything that you guys would like to see, for those of you all that are watching the replay, make sure you come back. Also, tell a friend to tell a friend. Bring another friend with you. If you're taking chemistry right now, bring other friends back with you so they too can become confident in chemistry. Okay? So you guys, y'all take care, and you all have a great rest of your evening. Until next time, have a good one.